Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. How are you? Hopefully everybody is fine, doing very well today. So today we will continue our online class. So this is our first chapter. We will discuss about the first chapter today, about the queuing theory. Okay. Okay. So this is first chapter, data communication BEE 4233. Chapter 1, introduction, basic queue theory. Okay. Okay, this is the overview of this course. 3 credit. So our subject is 3 credit. Why it doesn't happen? Okay. So I will update Kalam immediately this week lah. Okay, let's see. So this course is called data communication. Data communication. So the topic in chapter 1 basically will cover first queue basic theory, various queue models, okay, and 1.3 is applications of the queue model and strategies. Okay. Before that, I would like to say thank you to the owner of the notes, Sir Hisham, the previous semester lecturer for the previous semester of the subject. Okay, let's see Q basic theory. Okay, so first subtopic is Q basic theory. Q. So you know Q? Line. Okay, let's see the overview. Factors contributing to packet delay. So packet is like the information, and in data comm, sometimes the delay happens. Okay, so factors contributing to packet delay. There are typically 4 factors which contribute to packet delay in a network. Okay, so basically total delay is because of 4 factors. So among 4 factors, queuing delay is one of which most interesting and most complicated. So what are 4 factors? First is processing delay. Second is transmission delay. Third is propagation delay. And 4 is queuing delay. So this is what we going to touch today. Queuing delay is time spent by packet also known as data, sitting in a queue waiting to be transmitted into the link. The amount of time it needs to wait depends on the size of the queue. If the queue is empty, then it transmitted immediately. But if it's sitting behind other packets, then it needs to wait for the packets in front to be transmitted first. This is the common sense explanation. queue basic theory. In order to understand more about queuing delay, we have to take it step back and look the basic of the queuing theory. Then we will look at the simple queuing model, derivation, and then see how we can use to calculate the average network delay. So why we need to know about queue theory? We need to calculate the average delay of the network. We need to be able to predict the delay. Okay, what is queue theory? Queue theory is basically the mathematical study in waiting lines. Okay, so we have been very common, very used to queuing, or being in lines. The example are in everyday life, Starbucks, wherever we go to McDonald's or Starbucks, or we can see the vehicles at the traffic light, for example. If we go to shopping, grocery line, when we want to pay at the till. So all this related to, we need to queue. Okay, and in particular in this subject, it relate to packets in data network. Okay, so this is the point in this topic, this subject lah, packets in data network. So we can relate this queuing in data networks with the similar queues that we face every day. Okay, typically queue is formed when people arrive at the place to get some kind of service. Okay, in queuing theory, we create a model of the queue system so that we can predict the performance of the system for parameters like, first, average number of customers waiting. Okay, second, average time each customer spend in the line, and third, how utilize servers serving the queues, how the server is serving the queue. So this is parameters that we can discuss when we discussing about queue in general. Okay, so this is this is a component. This is a example of a queue system. Call it, this is a figure, shows the queuing system, common queuing system. So the components of a queuing system. So below is the representation of various component in queuing system. Components. So what is component? So basically, in queuing system we have arrival process. Okay, one is arrival process. Second is the queue lane. Third is queue discipline. Four is service pattern. Okay, so you have the customer arrival, and then he or she goes into the queue, and then enter the service. If you go to the bank, this is the counter, right? So there is one queue, and this one can go either here, here, or here. Counter 1, counter 2, counter 3, it can go. So this is service pattern. Sometimes you queue straight to the counter. And then after finish, then exit. Finished. Done. Okay. So this is finished. So this is the basically the basic components of queuing system. Okay. So what is that? So basically, components of a queuing system can be, there are four. At the basic level, consists of one or more servers serving the customers, one or more queues in which customer will come and line up. The length of these queues can be assumed infinite or finite to hold customers waiting for service. So there are four major components of the queuing system. First is arrival process, represent the customer arrival pattern. We will look at details later. Second is service pattern, how many servers or how many counters, for example, we have, and the speed of the service, which is called service rate. Okay, so the speed of the service at the server is called service rate. Okay, component number 3 is queue length, how many people a queue system can hold. Okay, so how many, either finite 10, 20, 200, or infinite. Okay, infinite, the queue length. And component number 4 is queue discipline. This represents if the queue will be served in first come first serve, FCFS. So you need to remember this term, FCFS, first come first serve, LCFS, last come first serve, random, or we have some more, let's see later. Typically it's FCFS, first come first serve, and that is what we will assume for the rest of the article. Okay, so for queuing theory, they have the model taxonomy. Okay, this is called queuing models taxonomy, this one. So in queuing theory, we use certain kind of notation to refer to various types of queuing system. The format of the notation is below, so you need to remember this. A, B, S, K, and D. A slash B slash S slash K slash N slash D. A, B, S, K, and D. So A, what is A? A is arrival process. Okay, so we have discussed this before. A is arrival process, inter-arrival times distribution. It can be either of these. MDG. M is represent Markovian or memory. D is deterministic. G is general distribution. Okay, so for A is arrival process. It can be M or D or G. M is Markovian, D deterministic, G is general. So this is A, arrival process for the first format, first notation in the format A, this one. So what is B? Next is B. Okay, the second notation is B, which is service distribution. It can be either of these, also M, D, G. M represent Markovian, D deterministic, and G general. So B also have three type of distribution. So the next notation, S is number of servers. S is number of servers. Yes. So this is the third notation. This is the second notation. Okay. The fourth notation, K. Okay, this is K. K is the capacity, system capacity. So it use K, capacity. The maximum number of customers in the system, including the ones being served. Typically, we omit this when it's infinity. So if there is no mention about K, it means it is infinity. Okay. Okay. The next notation, number 5, is n. N's normally represent number or size. Okay, population size. So usually we consider infinity for this. So n basically the population size. Okay, if it is too many, then it can be, we can say this is infinity. Okay, the last is D. Yeah, so we have 1, 2, 3, 4, 5, 6. 6 notations in the format. So D is the last notations, number 6. So D is discipline. Discipline means like the system, the way the queue acts or behave. Okay, so D is the queuing disciplines like FIFO, LIFO, random, etc. So we have FIFO, first in, first out. LIFO, last in, first out. Just now at the top we have discussed about first come, first serve. Bisa dengar kan? Okay. Last come, first serve. So something like this lah. This is first in, first out. First come, first serve. Last in, first out. Last come, first serve. Like similar. So for the majority, we only use the first 3 notations, A, B, and S, to represent a queuing system. Okay, so we will discuss about queuing examples in the next video. Okay, so for this time, that's all for now. We will continue in the next video. That's all. Okay. I don't want to make a very long video. So you just watch maybe 10 to 15 minutes each video. So okay, that's all for now. We will continue later after this. So thank you very much. See you later. See you next video. Bye.